So this is a fairly indicative part of what we make here at Micro. This part in particular is used as the mating contact for a throttle position control system. Basically means how much gas is going in and out of your car engine. Quality levels, well, about as tight as you can expect for wanting to control your car going into a busy intersection. We ship about, it's tight about 5 million a year of this product worldwide, NAFTA, Europe, China, Asia region. What makes this part unique is the fact that it combines a lot of our different skill sets here at Micro and a lot of our capabilities. This is an insert molded stainless steel insert. Has a 6-micron ID finish requirement because it gets welded onto the butterfly valve in the fuel injection system. It's over molded around an engineering grade thermoplastic in a segmented gear, zero flash mold requirement. After that, it's mechanically joined to what we call a multi-wire brush, which is something that Micro invented quite so many years ago. Uses the next generation in sliding contacts. That allows for better electrical signal performance over a life of an automotive application, which used to be measured in years, now it's in decades. So why don't we follow this part around and see how it's made. This is a Makino hard milling center, just coming to life right now, along with its sister there for CNC milling. What this allows us to do is take all of that sinker EDM work, all of those successive what we call burns, and that could be anywhere from 5 to 25 to make one cavity to make this part. Not only is that time consuming and expensive, but think about now we have to design up to 25 of these things. We have to build them, we have to test them, we have to measure them. It's all very, very time consuming. What this allows us to do now is actually go in with a cutter system and cut out directly into the hardened steel itself almost a finished product. All right? That allows us to go from, say, 25 of those burns down to 2 or 3. And that means 20–30% lead time reductions that we're working on right now for all of our mold delivery. You can watch this right here. Buenos dias.
Buenos dias. Good morning, sir.
Good morning, good morning. So in there you can see an actual mold cavity pocket. This is a test bed we're working on to validate the machine right now. But that is straight out of the machine. That used to take us weeks, it now takes us hours. So we have a lot of great hope for this. Our friends at Makino are doing a great job helping us train. Just like this young man you saw behind me here, who is going to be one of our leading experts in the field. So in here we have our molding area. What makes ours unique is the fact that we build everything from start to finish. And we generally use our molding capability as part of a greater project. We do a lot of shoot and ship product as big for medical devices and things of that nature. But any of our assembled product, any of our subcomponent assemblies rely on good quality plastics. And generally we like to be the single source of accountability on all the product we make, whether it's a metal part, a plastic part, the combination thereof. If the component doesn't work, the assembly doesn't work. That's why we make them ourselves. So this part right here is actually molded in this machine. It's not running right now, but we can give you a good idea of what it does. That end of arm tooling is about the only thing we buy when it comes to robotics and assembly. Everything else is made by us internally. The stainless steel insert is insert molded into the gear, gets loaded and extracted via the robot. You can see behind us here, this is for a different product, but a very similar technology. We're now using universal robots to pick and place and load all of our inserts within the cycle time of the mold. That allows us to keep costs to a bare minimum and also reduce our CapEx and machine utilization to the maximum possible. Everything you see designed from here down is made by us internally. We partner with people like Whitman and Sailor and others who are good at what they do, and the heavy stuff doesn't really fit the Micro brand. But everything done here is done by us. As we walk around, it's important to note that nothing in this entire assembly is made more than probably 50 meters away from anything else. It's also what makes us unique. We have stamping, molding, machining, tooling, automated assembly, warehouse, packaging, logistics are all right here. One-stop shopping for everything. This is our stamping department. This is what actually started the entire Micro brand 54 years ago now. We began life as a precision metal manufacturer, and we still do that today. The key to that was, as I mentioned before, is making our own tools. We couldn't find people that could make tools to the level of precision that we needed in order to make the products our customers demanded, so we had to build our own. Same thing went with stamping, particularly in the maintenance. Making a die is one thing. Being able to maintain it, run it over and over and over again to the exacting tolerances, again, we're talking about less than a width of your hair over 10 million parts, 100 million parts. So the ability to maintain is something we take very seriously. We also don't let it out of our control. We don't outsource it, we don't partner with it, it's done by ourselves. Gentlemen you see here and more like him, they follow the US German journeyman program. There's no shortcuts to building a great tool maker. Most of these guys have been on the bench over a decade. I will put them up against anybody, anywhere, anytime for the quality of work they do. We have all the nice EDM machines and hard milling centers. A lot of times in our business, we take what comes off that state-of-the-art equipment, put it on one of these 40-year-old Brown and Sharp grinders with a man who knows what he's doing. That gets us to the quality that we need to get to. That's why we preserve that art. As much as all the science in the world, you still need a little art. And we do our best to continue the education of these people. We just walked through the only wall in our factory. That's predominantly because of the noise and of the debris. Stamping happens to be I won't say dirtier, but it creates more debris than our other processes. Where a lot of companies have clean rooms, we have dirty rooms. And in here we're doing all of what we would call dirty, although still as precise, still as high quality, still as demanding. See, man Lester here and his partners, they're our mold maintenance, our die maintenance guys. These are, again, 12, 15-year on-the-job tool and die makers. They sit in the middle of the room. They work hand in hand with production. They're not in some other far away, locked room. They don't get to smell and feel and hear the problems of the factory. So we spent a lot of time on how do we make one team. And one team is good parts out the door on time, on budget. In order to do that, particularly in this area, you need integrated craftsmen into the work process. So here we have brooders that most of them are probably as old as I am. Still work, very, very solid. Each one of them has gone through a ground up refurbishing before it came here. The housings are actually still out being repainted in our new medical gray, but to give you an idea, they still work as well as they did the day they came here. So generally when we use a press like this as opposed to one of these larger presses or smaller ones, very rarely it has to do with how big a part we make because, well, we generally make pretty small parts. It has to do with the tonnage and it has to do with the bed size. Complicated parts need a lot of room to be made. These ones also are very, very stable at high speeds. We can run these up to 1,500 strokes every minute. You can take a nickel and stand it on edge and that machine won't budge. Very solid, very reputable. Sometimes new is great, sometimes tried and true is even better. Give you an idea of the balance, the yin-yang between the new and the old. Is a keying system used more and more around the world. What it means for us is speed and accuracy in our metrology. So we make a part, we make a piece of metal, typically the old way. You'd have to come up, put the part on this block, set it precisely, which I'm not going to even claim to know how to do it, but I do know how to work the comparator. You would then zoom in and inch by inch move these dials to get each and every dimension. This part has over 200 dimensions on it. You're talking about, again, well, a quarter of the width of your hair. Doing that 200 times, we run 8 cavities. If we run a sample lot, we have to get 200 samples. Don't do the math in public, but you can figure out it's a lot of dimensions. It's very, very time consuming. And yes, there will be an error every once in a while. It's human intervention. Here, I can take this part, I can throw it down there, I can press this button, and damn near instantly it gives me all the dimensions, real time, accurately. It also saves it all. We get SBC data, we get all the data that now we need to run a modern manufacturing company, because we're going from linear data to exponential data. This is where we start making a difference on how we increase the next generation of product. As I mentioned, this part sells in the millions. Its quality demands are 0.001%. That means 1, 2 are allowed to be bad. And again, let's go over those tolerances. Bad could be the temperature's off in this room. Bad could be one of the lots of material came in just a little off, we're out. One thing you can't do is put this together by hand. So what we've managed to do is create our own level of automation over the last, wow, damn near 30 years now. A lot of our competitors buy automation. It's easier to do. There's a lot of great automation houses out there, but they're there to make automation and to sell automation and make money on automation. We have a very different approach. We sell automation to run good product. We do it as simple as we can. We do it cost effective as we can. Because we own this building, we do it in the smallest footprint we can. And that's allowed us to create what we call our direct drive manufacturing systems. It allows us to do in one station what many of our competitors do in multiple. Here's a good case in point. This is a product used in an automotive application. It's a rear view mirror actuator. May not sound overly complex until your mirror's pointing in the wrong direction as you're driving down the highway. In this case, it was very, very tight price pressure on this product. We had to give our client the most efficient solution that pushed even our thinking around how we could do everything in one shot. So in this case, we take our stamping presses and we move them right to the assembly machine. So what was done in that room over there with the big machines going up and down and a whole department around it, we've brought right to point of use. So the material comes in from here, metal, gets stamped, goes right into the assembly machine. Plastic is brought in, that's made right over there, goes into a tube, that's it, it's done, it's out the door. So you have two products assembled, high volume production, I believe single digit PPM quality delivery expectations. So here we have this product finally coming to life. We have a series of wire brushes brought in over here behind me that I can't really show you all of it because it's proprietary. But again, we do in one station what our competitors do in multiple. Plastic comes in over there, metal comes in over here, gets joined together mechanically. Everything from then on is vision systems and checking both mechanical and electrical properties. So vision system here, force check. We have a couple of critical dimensions on the plastic, so we're now checking that as well. Then automatically fed. We actually even make, there's a protective cap you can see over there. We even mold that ourselves. In the reusable trays that get shipped to our client, get actually wrapped up, then shipped to our client. No human touches the product from here on in. That's how we get the quality levels. This is the very first product thankfully, there are not that many bad parts. This is the very first product we made here in Costa Rica 18 years ago. Looks kind of like a hockey puck. It's a air-proofing switch used in any gas-fired appliance, either in your home or in a commercial application. What does that mean? It's a safety device that before any gas is ignited in your home or your place of work or your kid's school, that this is the sensor that makes sure that there's a vacuum and the carbon dioxide is going to go out of the building, not kill all the inhabitants. We've been making this part for about 20 years. We own about half the US market, and we have some very esteemed competition on the other side, but probably going to be taking that over pretty soon. While we do build more and more automation, and it is creeping into every aspect of what we do, there's still a case to be made for good manual production. So here, we're making about 4 to 5 million of these switches a year. I think we have 332 varieties of the same product. A lot of using different components, some different electrical set points, some pneumatic set points, very, very complicated. And in some cases, we still can't figure out how to make automation do it as well as the people sitting here next to me. So, great manual dexterity, very, very, very good attention to detail, and I think that's really what we found originally and why we stay here in Costa Rica. The attention to detail and the ability to work in the level of precision that we need is what makes us in this country a good fit together. Anyway, this line has probably changed its format, I don't know, over 100 times. It used to be very big batch processing. It used to be very convoluted, a lot of whip stations here, there, and everywhere. Now, single piece flow, semicircular, U-shaped, all the fun lean terminologies that a lot of people will pay a consultant to come in. We let them change this line with their leadership, with our engineers, with whoever they need to do. As long as they don't change the form, fit, or function of the product, they're allowed to optimize the means of production. That's why I said I can't even count how many times we relayed this line out, because we use it as a test bed for lean practices as well. We've seen easily a 400% throughput in the manual lines since implementing lean practices and allowing the teams to experiment and innovate on the line. This line here is our latest thinking around how to deploy technology and how to deploy automation to fit our needs. We have about 110 people manually assembling the progenitor product, of which this line will now free up all but about 10, which is great because we've got a lot of other things we need them to be working on. Again, rather than outsourcing the design and the build, we decided to tackle this project ourselves for a number of reasons. One, there's a lot of different things going on here. Any one automation house would have a hard time taking the holistic approach that we're taking. Two, excellent learning example experience for our local team. This entire machine was built here in Costa Rica. It came to life here, it was groomed here, continued to be designed here. So a big step forward in our evolution from that, hey, make everything anywhere else, manual assemble here in Costa Rica and then get it back out. This building and the people in our facility here in Costa Rica has gone from, the typical cost center to our profit center, to what we show the world we can do. And this is becoming the forefront of that thinking. So, feeder bowl technologies are bringing in insert molded parts that are made over there in our molding department. Stampings are made right over there again. All the tooling's made right over there. Part comes in, we're using laser engraving where we used to use paper labels. We're now doing real-time engraving into the plastic, which allows us to take our changeovers from 10 minutes to about, a tenth of a second, really. We've mimicked that press at the assembly line philosophy that gets away from this local optimized departmental approach to manufacturing to look at more at the flow. Here the flow is, we have a critical but friendly stamping that we can take in its bare form, made somewhere else, and then singulate it, integrate it into the line right at the spot. Again, less touches, less chances for failure, less chances for quality escape. Down here you'll see a chain drive, looks kind of like a chainsaw. We've looked at a number of options, including magnetic rails and rotary tables and all the like. Again, we believe simplicity is genius. This is 99.9% uptime, very simple, very easy to maintain. Actually never goes down, but if it were to, it's a simple stepper motor, simple chain drives, everything off a piloted nest. Again, some things change, some things never change. Simple, good, quality steel, piloted in on a flexible drive will get you all the all the exacting tolerances we need in order to make a good product. The midsection here is populating, I believe we have 5 different metal components going in, from 4/1000ths of an inch thick to 40/1000ths of an inch thick. Some are terminals, some are blades, some are springs, all going in mechanically. So sometimes it makes sense to insert mold. This case obviously is way too many components. The trick now is to get them all in under the cycle time of the assembly line. Our next step is to automate the hand loading, which is being done right now using some really cool soon to be divulged technology. Since it's a pneumatic switch, we have diaphragm, which translates pressure into mechanical force. Those get populated offline but integrated mechanically. And then from here on in, we're doing all of our checking on the system. Vision systems start, make sure that everything is exactly where it's supposed to be, both before and after the diaphragm goes in. After that, another piece of plastic, our housing is made over there, gets assembled. Then from here, the robots have to take over because of the heat and because of the calibration needs. What you see over there are welding heads. They're using heat welds. So not the best ideal place to have somebody sticking their hands in and out of. So we're using universal robots. Our friends there have been very helpful in spec'ing the right solutions for us. But we're able to now heat stake in a very simple, very, very secure methodology. Again, 99% something uptime, very repeatable, very robust, no debris generation, easy to maintain. So we're still grooming all of these test stations. The entire project is coming to life around us real time. One of the things when you build everything yourselves, you don't have anybody else to blame but yourself, so there's a lot of different moving parts that we're tackling simultaneously. But the end vision is to have all of these calibration systems online. From there, the robots take it, put it into a box, again, not touched by any human, gets a label on it, out it goes. We're actually now toying with the idea of can we 3D print the packaging on demand at the end of the line, which would then take it one less step of human intervention and go straight from here, actually get it wrapped right here, label right here, possibly automatically to the loading dock. This series of parts is made for a sensor that we make for the ConAg industry. Big Caterpillar, John Deere, people like that. They use this, bolt it right into a transmission, probably several times the size of this machine, into a tractor that barely fits into this room. Very robust, very sturdy, but also very precise. This is a safety product that will tell the operator if there's any filtration issues on the lubrication systems in the transmission. When you think about the second, third order of effects, if this part doesn't work, it shuts down a $400,000 transmission on a $5 million tractor, probably on a $50 million a day mining operation. Right? High consequence of failure. We've been the single source of this product for about 20 years. We used to buy these once upon a time on the outside when we were making them back in the US. As we built micro technologies around us, particularly around the tool and die making and building our journeyman tool, technical resource people, we took another look and said, maybe we can start to do that ourselves. And we insourced in a world where most people are outsourcing. We like the idea of doing the next obvious thing ourselves. So good tool makers, good practices, good demand, steady clients. Why not bring something like this in-house and add to our core competencies? And we did that about 10 years ago. This part is now by far the largest thing we make. It gave us about a 70% cost reduction from buying it on the outside. But more importantly, it allowed us to get into what is now another core competency, micromachining for us. But where all that fluid is squirting, there's a very, very, very small piece of metal sticking out. That's the latest part we're making. This is now for medical devices. Oh, here we go, thank you. So I don't know if you can see what's in this bath here, but each one of those parts, again, has about 50 dimensions on it. I don't know how they make it. Anyway, some cases you have to go beyond the human side of things and let the machines take over. We're partnering with our friends at Citizen to launch an entirely new and exciting area for us, particularly around medical device manufacturing, and that's micromachining. So we keep adding. I think we have 4 machines scheduled to come in yet this year. We continue to actually go smaller and smaller to see how far we can actually push this technology. Give you an idea of scale, you can barely see that monitor moving and see the amount of shake it gives the part. Thank you. All right, so, give you an idea of scale. If you can zoom in, you can see the head of that tweezer. Yes. Yeah. So again, that was that. So here we have a clean room assembly operation for a medical device product. I'll see if I can find one in a minute, but it's used as a vascular introducer. What does that mean? That means that before any guide wire or some type of invasive product is inserted into your veins to do some kind of catheterization or biopsy or something, there's a sheath that goes in and protects the vein itself. This is what we're making here. What you don't see in our building are huge clean rooms, hard walled like everywhere else. People say, well, why don't you have clean rooms? Well, we do. They're just a lot more specific. Why? Because we take a lot more care to the environment, the general environment of our building. We have a controlled environment. It's not super clean, but allows us to use modular, flexible clean rooms rather than double wall-sided, very expensive, very hard to move. If you put a hard side clean room in here, this project goes away, well, we need to use it over there. All of a sudden you can't do that. This allows us to mold outside of the clean room and do all of the finishing, packing work inside here, which will then get packed up, then sterilized by our client, and off it goes. This is a project done for a tier 1 medical supply company that was actually looking to come here to Costa Rica, then decided, since Micro's been here for so long and we've developed a PhD in what not to do in this country, why not partner with us? And this is the end result of that labor. We ship about, I don't know, I think it's about 100,000 units a month now, all over the world, but actually a fair amount of it right here in Costa Rica. Inside here we're doing RF tipping, which is actually taking the hard cut edge of this extruded tube, which you wouldn't want stuck inside you in its natural state, putting a nice round, very specific edge on it. Then we're manually inspecting, make sure there's no debris, there's no caught edges, nothing again that would create an unpleasant experience for the patient. So as we grow, you'll be seeing more and more of these modular clean rooms. Medical device is a big part of our growth strategy, but we also believe in flexible manufacturing as a key towards any modern approach.